Okay, so I think we have enough tools under our belt at this point that we can solve a simple exponential equation. And what you're seeing on the page here may not look so simple, but it's actually not too bad because I have an exponent here. I have an exponent here, which is just a linear exponent. In other words, there's no x squares, there's no factors. It's just 2x minus 3. So we need to work through this equation and get it into a form where we can solve it. We can use a calculator for this one. The problem said we should solve it to within 2 decimals. So here are the steps that you do. Number 1, isolate the exponent. In other words, get the exponent by itself. Then you convert exponent. We're going to convert exponential to logarithmic form. And jumping from exponential to log or log to exponential is often the way you solve these equations. So it helps to be good at that. We've gotten some practice before. And then once you're in log form, you evaluate logarithm. Okay, so you'll see how these steps work out. So step number 1, I'm going to isolate that exponent. I want the 4, not even this whole thing. I just want 4 to the 2x minus 3 by itself. So let's work this through and see if we can do that. I'm going to, let's just write this again here. Negative 6 times 4 to the 2x minus 3 minus 9 equals negative 462. And the first step in isolating this is adding 9 to each side. Okay, I'm going to get closer to having the 4 by itself. So that produces negative 6 times 4 to the 2x minus 3. And the minus 9 plus 9 cancel out. On this side over here, we have negative 453. Okay? And then you divide each side by a negative 6. All right? That'll get us even closer to 4 by itself. So we get 4 to the 2x minus 3, and that's going to be equal to 75.5. Let me just double check and see if that's right. Yep, we're good. Okay, 75.5. So now what I want to do is find some way to deal with this thing. And if we go back to our list, what was number 2 on the list? I've isolated the exponent, and now I need to convert the exponential to logarithmic form. Well, let's see how we do that. If you remember how we convert logarithms, any logarithm that is written in this form, and I'm going to say, what was this? No, not A. The basic definition for logs was if you have a base raised to an exponent, that equals the argument. And in log form, that's this. Log base b of the argument equals the exponent. So can we use this somehow, this basic definition of logarithms, to turn our equation right here into a more useful form? Let's try it out. So my base is 4. So this is going to be logarithm of base 4. My exponent is 2x minus 3. That's going to go over here. And my argument is 75.5. So logarithm base 4 of 75.5 equals 2x minus 3. And at this point, you can probably see why this said to use a calculator. There's no way you're doing log base 4 75.5 without a calculator. And some calculators can just grind through this as it's written. Many cannot. So you need to know how to use the change of base formula. It's not hard. You just say log of 75.5 divided by log of 4. That's what 2x minus 3 is going to be equal to. So let's see what that is. Let's see. Log of 75.5 is going to be 1.87795. And log of 4 is 0.60206 equals 2x minus 3. So now I'm going to divide those two things by each other. We're going to say log of 75.5 divided by log of 4, and that gives us 3.1192 equals 2x minus 3. Okay, so now we can solve this the normal way that we're used to solving equations. We're going to get x by itself. So we say, well, 3.1192 plus 3 is going to be 6.1192 equals 2x, and now divide each side by x, and we get x equals 6.1192 divided by 2. It's going to be 3 something. Yep, 3.0596 equals x. So the other thing you should do when you're solving one of these equations is just make sure that this is allowed by the equation. As you look back at the original, let me just grab the original equation here. We're going to bring this down, talk about this just a little more. Look at this equation. Is it going to be okay to put this number of 3 point something into the equation? Well, exponents can be positive or negative, so I don't think that's going to be an issue. And you can even try it out. You could try out putting this thing in here, and you can say, double check your work, -6 times 4 to the, what was 2x minus 3? Remember? That was 3.11. Just save ourselves a little time there. 3.1192 minus 9. And let's plug this into a calculator and see what we get. So we get, I'm going to use my calculator here. 4 to the 3.1192 minus 9. So what do I get? I get negative 461.9985. Okay, pretty close. I think we did a good job. You can get even closer, of course, if you have more decimals, but really, rounding within 2 decimals is fine. We could have called this x equals 3.06, and it would have been just fine too.